Good day, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Methala Chia. This lesson is brought to you by Gauteng Department of Education in collaboration with the Saibono Discovery Center. Boys and girls, I am with my co-presenter here, Miss Nikiwe Zulu. She is sitting next to me here. Boys and girls, you must remember now, we are approaching our June examinations. So this lesson is going to be very helpful in preparation of the June examination. Our focus for today, it will be under what? Under maps and plans. But the main focus, remember last term, or last week, we were busy with measurement. We are done with measurement. We did the conversions, we did the volume, the area perimeter, the BMI, we did everything under measurement. Now we are starting the second part of paper 2, which is maps and plans and other representation of the physical world. But the main focus for today, it will be the scales. By the end of this lesson, boys and girls, you should be able to work with number and bar scale. This is not new. You have done it since grade 10. So now you are at the final stage of applying the skills that you have learned in grade 10 and in grade 11. So we'll be focusing on, or we'll be working with number and bar scale. Discuss the advantages and disadvantages, discuss the disadvantages and advantages of bar scale and number scale. Expressing the number scale as expressing number scale as a bar scale and vice versa. Determining the scale used to resize the image. Use the given scale to do the calculations. The last one, calculating the actual length of the drawing or image of the object. You'll see it's going to be very nice with this session, boys and girls, because this topic is one of the easiest. I always say when I work with the measurements, because we have done the conversions, so it will be easier for us now to do all these calculations when it comes to scales. If you did not do the conversions, I think you need to go back. Let's check what is it that you should be knowing by now. In grade 10, in grade 11, even in grade 12, we're focusing with, or we did the ratios and proportion. So we know when we say the ratios, when we work with the ratios, the units must be the same. If I'm working with the meters on the left, remember the ratios are written as 1:2. So if it says one, maybe for example, on my left hand side, it is 10 kilometers, or let's take the kilometers or the meters. If on my left hand side is 10 meters, on the right hand side also, it must, this 10 kilometers or this 10 millimeters or whatever unit that I'm having, the unit on the right hand side must be the same. So meaning when we work with the ratios, it means the units are the same. But when we work with the proportion, like when you buy petrol, when you buy petrol, we buy petrol, the number of liters, and then we pay a certain amount of money. Similar to the distance, when you travel, you know that you'll be traveling a certain distance and then with a certain speed. So that one, it's the proportion. We are working with two different units, but with ratios, the units are the same. And like I have already mentioned, we did know how to measure the distance and length when we're doing the conversions. And then also we did the conversions between units of length, like from kilometer to meter, from meter to centimeter, and then from centimeter to millimeters. We have done those conversions, and we know the units of measurement. If they say your answer must be in centimeters, so that means your units must be in centimeters. And boys and girls, it's very important that you don't forget the units. because sometimes you find that the examiner will penalize you for not writing the units. It's very important. And also we know how to calculate the distance and length on a map. We have done it in grade 10. It's not like it's for the first time you are seeing it, but we have already touched it on in grade 10 and grade 11, when we are given, especially in grade 11, when we're given the map and then we had to measure the distance on a map. Now, boys and girls, here is our baseline assessment. I want to know if you are able to remember what you were taught in grade 10 and 11. Let's have a look at number 1. It says, always follow the instructions. Choose the correct answer from the given options below each question. That's an instruction. You must choose the correct answer from the given options below each question. Question 1. What is the meaning of the scale 1:10,000? And after you read that, 1:10,000, let us go through the options that are given. We are given 3 options, A, B, C. Option 1, it says 1 unit on the map represent 10,000 units on the ground or in reality. On the ground or in reality. Option number 2, 1 unit on the map represents 10,000 units on the map. Option number 3, or option number C, 1 centimeter on the map represent 10,000 kilometers on the ground. So boys and girls, I hope you have selected the correct answer. What is our correct answer? I know you are raising your hand and even your teacher is aware. Teacher, please point one of the letters there. Did they say the answer is A? Very true. Yes, the correct answer is A, because here now we are saying 1 unit on the map represents 10,000 units on the ground or in reality, not map into map. Remember, on map it's on paper. So now in reality, so it means when you talk about the scale, you'll see when I explain further to say when you talk about the scale, something that we see with our naked eyes, it can be big, it can be small, like a mosquito. You know, the mosquito, it's so small. We struggle to see the mosquito, but when we buy a can of Doom, they will show us the mosquito. Then that means the image has been enlarged. It has been made bigger on the paper, because the mosquito, it is very small. But other items, like for example, a calculator. This calculator, you know, when you see this calculator, you know, okay, fine, this calculator in reality is this big, but on paper you'll find it's smaller. So meaning the image has been resized. Let's go to number 2. A number scale is also known as. A number scale is also known as A bar scale, B, a line scale, C, a ratio scale. Who's having the correct answer? I can see Mpo is having the correct answer. She has raised her hand, and then the answer is C. The number scale is also known as what? As a ratio scale. Remember, now it's a number, it involves numbers. It's then we say 1:2. So that means it is in a ratio form. Now let's go to number 3. If a map has a scale of 1:50,000, 1:50,000, and the distance of 2 centimeters is measured on the map. So meaning on the map, on paper, remember map is on paper. On paper, when they measured a distance of 2 centimeters. And the actual distance would be equals to what? In kilometers. So here 1 is to 50,000, and then 2 centimeters is to what? We want to know this 2 centimeters is equals to how many kilometers in reality. Who's having it? Oh, Sean. Sean is saying the correct answer is in 1 kilometer. This one, boys and girls, you can't just choose the correct answer. You have to do what? Some calculations. Because like I said to you, but I am not going to do the entire calculation, because when I explain, I will show you exactly how to do this calculation. So, but just in short, you will do it on your own. When I do my explanation, you'll get to understand. Remember, we say 1 unit on the map represent 50,000 units in reality. So this 2 centimeters, it was measured where? On the map. And then we want to know on reality, it's equivalent or is equal to how many kilometers. I am not going to assist you, but you can do it by yourself. And remember, these units, okay, let me stop there. Let me stop there with number 3. I will deal with it when we go deeper into the calculation. Remember, this one is just a baseline. I want to see what you know and what you don't know. Number 4, if a bar scale shows 1 centimeter on the map, represents 100 meters. 1 centimeter on the map, meaning when they measure 1 centimeter, and then it represents in reality 100 meters. A distance of 3 centimeters is measured now. The distance of 3 centimeters is measured, and then this distance will be equivalent, or the actual distance will be equals to how many meters? 1 centimeter on the map represents 100 meters in reality. Then 3 centimeters on the map will represent how many meters in reality. Let me just keep quiet for a second and see who's got the answer correct. Ma'am, say, do you see who's raising their hand there? Are they giving you the correct answer? What are they saying? Let's go through quickly their options. A, 300 meters. B, 3 meters. C, 30 meters. Now the correct answer will be what? I'm checking the time on my side as well. The correct answer will be A. Someone got it correct in class. Boys and girls, can you see? It's so simple. 1 centimeter is equals to 100 meters. And then 3 centimeters will be equals to what? 3 times 100. It will give me 300 meters. Then number 5, boys and girls. From the statements below, which best describes the advantage of a bar scale, or the advantage of bar scale? From the statements below, which best describes the advantage of bar scale? Let's go through the options. A, measure the length of one segment and measure the distance on the map or plan before calculation. Is it an advantage? I don't know. Number B, resizing the map or plan. The ratio scale becomes inaccurate. When resizing the map or plan, the ratio scale becomes inaccurate. I don't know. You need to tell me. That's number B. Number C, resizing the map or plan doesn't affect the bar scale. Remember, we want the best advantage of a bar scale. Resizing the map or plan doesn't affect the bar scale. Let me just be quiet and check my time. Who's got it, ma'am? Yes. Okay, they got it. They're saying the answer is C. Yes. Because now with a bar scale, you are given a bar, and then that bar, whether we resize or not, whether we resize the map or not, the bar scale stays the same. So it does not affect the calculations, because the bar scale is it remains the same, doesn't change at all. The map, whether it's small or big, so the bar scale remains the same. Number 6, choose the correct disadvantage. Choose the correct disadvantage of number scale. A, resizing the map or plan, the ratio scale becomes inaccurate. B, resizing the map or plan doesn't affect the ratio scale. C, measure only one distance before calculations. Who's got it? Let's see. Are you ready? Do you have the answer? The correct answer? Yes? Okay. Yes, the correct answer is no. Is it C, measure only? No. Is it B, resizing the map or plan doesn't affect the ratio scale? Now, resizing the map or plan, the ratio scale becomes inaccurate. Yes, the ratio is the correct answer is number A. This is our correct answer, not number C. And boys and girls, you must remember, when you do this, here we are talking about the disadvantage. The disadvantage. That's what we are talking about. And you saw that we did 6 baseline questions up to so far. And then each is 2 marks. Can you imagine? Just by answering the correct answer, already you have 6 multiplied by 2, 12 marks in the back, just by choosing the correct answer. So, boys and girls, we know that each and every single topic has its own terminology. So, for the scales, this is the terminology that you need to be familiar with. What is the scale? The scale determines how many times smaller or bigger an object shown on a plane or a map is than in actual size. So the scale, we say, it determines how many times smaller. It means if it's big, then it will be shrinked. It will be small, small, small up until it fits where on the plane. Or if it's too small, and then it has to be enlarged on the plane so that it becomes visible. An object shown on a plane. So scale, we are talking about the plane A versus the actual size. In reality, we know the calculator is this big, but on paper it will be resized, it will be made smaller so that it fits where on the paper. Can you imagine if I take the entire calculator and then make the measurement to be exactly the same in your question paper? How many pages are we going to use? It means you're going to use a lot of paper when we make some copies for you. So it is best what you do, we resize this actual size of the calculator. We make it smaller way on the paper. And then now the other factor, it's a scale factor. A scale factor, the factor by which the dimensions. A scale factor is the factor by which each dimension of the actual object is either reduced for larger objects or enlarged for smaller object. So a scale factor, it means it's a factor that says you need to reduce this to this. For larger object, we need to reduce it to smaller sizes, to a smaller print, or smaller sizes. Or maybe if it is too small, we have to enlarge it. So we're saying the scale factor, it says enlarged object, smaller object we enlarge, and the big object we reduce. And then, for example, 1 is to 5,000. 5,000 this 5,000, remember we say 1 unit on the map represents, okay, yes, 1 unit on the map represents 5,000 units in reality. So this 5,000 is a scale factor. So it means the item that we are talking about, then it will be either reduced 5,000 times smaller or enlarged 5,000 times bigger. So it can be 5,000 bigger or 5,000 smaller. So the 5,000, it is our scale factor. Then the number scale. A number scale such as 1 is to 20,000, it means that 1 unit on the map represents 20 units in real life or on the ground. So 1 unit on the map, when they measure, I know you'll see this ruler to be too small, but you have a ruler with you. There's no way you're going to work with scales without a ruler. A ruler must always be present. So now that means this simply says 1 unit, so 1 centimeter on the map. So meaning just that 1 unit that you are referring to on the map will represent 20,000 units in real life. Let's have a look. Another example that comes to my mind, a house plan. When you buy a house, before or if you want to build a house, remember you need to have a plan. That plan, it will be resized, it will be smaller. That means they will draw your house in a smaller version. You'll see your house in a smaller version to say when it's completed, this is how it will look. These are the dimensions. Your rooms will be having these dimensions. Remember, we did the dimensions when we were doing the perimeter, area, and volume. So we're talking about the dimensions when we're doing that topic. So now we know when we talk about those dimensions, if they say the length of the room is 3 meters and then the width of the room is 2 meters, so we know that that room, this will be the sizes 3 meters and 2 meters, 3 meters by 2 meters. But in reality, it means on paper they will measure the 3 meters. Remember now, this is the size of a meter. This is a meter. When we do it physically, this is a meter. Now, can you imagine this is a meter? Do we have an A4 size that is this big? No. So that means we have to reduce this size. The 3 meter must be made small. So that's why we use a number scale to either enlarge or reduce. So we say 1 unit on the map represents 20,000 units in reality. And this number scale, boys and girls, it does not carry what? The number scale does not carry the units, the centimeters, the meters, or kilometers, because that will be guided by the question. Let's continue, boys and girls, with our terminology, the bar scale. A bar scale presented as a picture. A bar scale is represented as a picture. It means that if you place a ruler next to the scale, you'll determine how many centimeters represents the specified kilometers. You will see when we do the bar scale, what do I mean when we say, you see the picture of a bar scale and you have an idea of a bar scale, how it looks like. And then what you do, you will take a ruler, you measure the size of the bar. And then after measuring the size of the bar, it will tell you how many centimeters. And after you got the centimeters, you know that in real life, that number of centimeters, the measurement that you have measured on the bar, they will represent a certain number of kilometers in reality. That is a bar scale. And then the scale drawing, a diagram of a real life object drawn in proportion. That is a scale drawing. Usually you'll find that sometimes when they draw, like in our paper, they will say the drawing or the diagram is not drawn to scale. So it means they have drawn the diagram but not to a certain scale. So it does, when they were drawing, they did not follow any scale. So that means when they say the diagram a scale drawing a diagram of a real life object drawn in proportion. So they have used the scale. And then the distance as the crow flies. What does that mean? A straight line distance, the shortest and the most direct route, literally from dot to dot. With this one, boys and girls, you know, when I measure on my map from, say, I measure from Vanderbilt to Kyalami, from Vanderbilt Park to Kyalami. Yes, in real, it is round about 90 kilometers. But on paper, can I draw the 90 kilometers? No, remember it's 90 kilometers, but I use N1 to come here. So I'll be turning somewhere, I'll be doing this. But on paper, then I just use what? My ruler. Then that will be a crow fly, because I'll be measuring from one point to the other. From Vanderbilt, I will place a dot there on Vanderbilt, and then check Vanderbilt Park, and then check Kyalami on the map, and then I draw a line. Then I measure according to the ruler. Then I will be able to give you the distance, meaning in a straight line. So boys and girls, let's continue with our lesson. Number scale, also known as a ratio scale. A number scale is also known as a ratio scale. The scale of the map is always written as a map distance to actual distance. So meaning it will be map distance is to actual distance. The scale is expressed as a ratio, and this type of scale contains a special ratio, namely a unit ratio, which means it will be 1 is to something. 1 is to something. When they say write the scale in a form of a unit ratio, they want you to simplify the scale to say 1 is to something. And then the number scale is written as a ratio. No units are used. Any unit of measurement can be used. So when you write a number scale, boys and girls, no units are to be used. You don't include the units. You just write 1 is to 100, 1 is to 50,000, or whatever scale that you have. 1 is to, in a unit ratio. You don't include. Like I said to you, the units, where will they be added? They'll be added on in a question. You'll be guided by the question to say, okay, the units that they have measured, was it millimeters or was it centimeters? That one will come from what? That one will come from the given information on the question. But when you write the scale, no units. Don't make that mistake of adding the units to say 1 centimeter on the map represents 10 millimeters or represents 100 centimeters. No units. Just one unit on the map represents 100 units in reality. There's the example. 1 is to 20,000 can be explained as 1 unit on the map represents 20,000. So meaning, don't make a mistake, 1 unit on the map. 1 unit on the map represents 20,000 units in reality. It will represent 20,000 in reality. Now, with the number scale, what are the most appropriate units we can use or we can measure on paper? What are the most appropriate units we can measure on the paper? We have 2 units, only 2. Millimeters and centimeters. Millimeters and centimeters only. Only those 2 units we can measure where? On a paper. In reality, it will be in meters, in kilometers. That one, it will be in reality. But on paper, we only use 2 units. Millimeters or centimeters. So now, remember on the slide before, We said when we write the number scale in a ratio from 1:20,000. So that means when we look at the question, they will guide us. They will say, okay, 1 millimeter on the map represents 20,000 millimeters in reality. Remember the ratio when we started the pre-knowledge, I said we are working with same units. We are not working with different units. Proportion is the one that is working with different units. And then 1 centimeter on the map represents 20,000 centimeters in reality. So if you use centimeters, it will be centimeters also. If we use millimeters, it must be millimeters. And then the appropriate measurement units of length or distance to be used in reality are meters or kilometers. I've already mentioned this. And then we have to convert from centimeters or millimeters to meters or kilometers. So meaning on the map it's millimeters. 1 centimeters or 1 millimeter is equals to 20,000 millimeters or 20,000 centimeters. But when it comes to reality, then we have to convert those 20,000 centimeters to either kilometers or to meters, because that is reality. We make them bigger. On the map they're small, but in reality we enlarge them. So then the example, the actual example, a map has a scale of 1:100,000. If the distance between two cities on the map is 6 centimeters, what is the actual distance in kilometers? Now, where do we go? This is just an example, boys and girls. You go back to your scale quickly. I will just show you. And then we say 1:100,000. So remember we said this means it's 1 centimeter on the map is equals to 100,000 centimeters in reality. Then they are telling us that this is 6 centimeters. The distance on the map is 6 centimeters. So when they measured from distance A to distance B, between the two cities, they got 6 centimeters. And then we'll take the 6 centimeters, we write it here. It will come under the map because they said it's map. And then we want to determine the actual. Now for us to determine, then we use our Buccaneer method, the cross multiplication method, and then this one we just multiply. And then we say now the unknown, it will be equals to 6 centimeters multiplied by what? Remember now, we said we don't use any units. Am I correct by writing the units? Yeah, because we're given the units as centimeters. So we multiply by 100,000. And then quickly we say 100,000. We multiply it by 6. And then we'll get our answer to be 600,000 centimeters. But is that the correct answer? No, they said your answer must be in kilometers. Where do we go now? We go back to our usual. We did the conversions, centimeters and the millimeters. And then we said from kilometers to meters, we multiply by 1,000. Don't forget this. And I always love to do this so that I don't forget. Then I know I have to multiply by 100 from meter to centimeter, and then from centimeter to millimeters, I multiply by 10. Now this one is from centimeters. Now we are taking it back to what? 2 millimeters. From then it will be from centimeters to kilometers. And then that means I have to divide here. Here I divide by 100, and then here I divide by 1,000, and then that means it is 100,000. So I'm going to divide this answer. For the sake of space, I divide this answer by 100,000, and then it will give us what? 6 kilometers in reality. it will give us 6 kilometers in reality, because we are going to divide by what? 100 multiplied by 1,000, it will be 100,000. So we're dividing by 100,000, it will give us 6 kilometers. Now let's go to a bar scale. This is a picture. Remember we said a bar scale is represented in a graphic, or we call it, a bar scale is also called a graphic scale or a linear scale. So it is in a form of a picture. Here is a picture of our bar scale. And then when you look at this, remember this words, that sometimes a bar scale is called a graphic scale or a linear scale. And then the bars of a certain length are used to show the scale of the map. So now, the bars of a certain length. So when you work with the scale, with the bar scale, so you take your ruler, you measure from this point up until here to say how many centimeters. And usually I prefer, or I would advise that you measure using the millimeters. And you know your ruler, the millimeters, it will be having those small lines that will show us exactly, you'll be exact when it comes to millimeters. And then you just check if you have used the millimeters sorry, to measure, and then at the top, remember you just flip your ruler. Okay, if it's 1 millimeter, and then at the bottom it will be 10. 1 centimeter will represent 10 millimeters. 1 centimeter on the map, on the ruler, represents 10 millimeters. Then you just check, okay, I have used my ruler, I have measured the bar. So I know that this bar only, when I measure it, if it says it's 1 centimeter, that 1 centimeter will be equals to what? 1 kilometer. So meaning if I measure the entire bar from this point to this point, then I get the units. So those units, say maybe when I measure, I get it to be 4 centimeters. Then I will say 4 centimeters is equals to 4 kilometers. So I know that the 4 centimeters will represent 4 kilometers. And then the bars, okay, I'm done with this one. Bars of a certain length are used to show the scale of the map. And then each piece of the segment represents the given distance. Like I have indicated to say now, if it says 1 centimeter, I know it will be 1 centimeter. 1 centimeter, I measure again another 1 centimeter. That means it will be 3. And then the last one, if I measure the entire bar, it will be 4 kilometers. And sometimes, boys and girls, it's best if you measure the entire bar. You measure the entire bar and then you convert the bars. Now, as you can see, I have said 1 centimeter. Say, suppose I've measured when I was measuring from 0 to 1. And then even on your ruler, when you measure, you start with 0. You start measuring from 0, not from 1. You start measuring from 0 to 1. And then you say, okay, fine. From 0 to 1 centimeter is equals to what? 1 kilometer. Then I measure the entire bar. I can now convert the bar scale into a ratio scale. So each piece of the segment represents a given distance. By measuring a map distance between 2 points and comparing this distance with the bar scale of the map, you can work out the distance between 2 points in reality. So that means you'll be converting the bar scale into what now? Into a ratio scale, as I have done now. Say suppose I've measured, then I will write it as 1 centimeter is to what? Is to 1 kilometer. If I have measured it to be a centimeter, then I'll say 1 centimeter, 1 bar is equals to 1 centimeter. So that means 1 centimeter is equals to what? Is equals to 1 kilometer. 1 bar is equals to 1 centimeter. And then that 1 centimeter is equals to what? Is equals to, that 1 bar is equals to 1 kilometer. So it's the same. Don't confuse yourself. So I have already explained this one. You see the way I was showing you. You take your ruler, you measure exactly. as you can see now, from this example, they are saying to us, you started measuring from 0 and then up until 2 millimeters. As you can see, it says 2 millimeters. The smaller parts are 2 millimeters, but the numbers they are in what? In centimeters. So now you know, okay, if it's 0 to 2 centimeters, that means the 2 centimeters represents 1 bar. So meaning 2 centimeters will be equals to what? 10 kilometers. And then 4 centimeters, according to the ruler, 4 centimeters is equals to what? 20 kilometers. So now it says, in the bar scale above, you can see that a measurement of 4 centimeters on the bar is equivalent to 20 kilometers in real life. So when explaining the meaning of the bar scale, you say bar scale is you say 4 centimeters on the map represents 20 kilometers in reality. There you go. I wrote it. 4 centimeters on the map. Remember we said here it is the map versus what? The actual. So it means you convert the bar scale into a ratio scale. So it will be a map is to actual. So the map, we measured 4 centimeters, as you can see on the picture there. And then this 4 centimeters, according to the bar, is equal to what? To 20 kilometers in reality. So you see, boys and girls, it's very easy. The answers are there when it comes to the scales. Now, let's quickly have a look at this one. The bar scale alongside can also be converted into a number scale. I've shown you. We have written in a ratio form now. We said 4 centimeters, which is the map, and then is to 20 kilometers, which is the actual distance. And then step number 2, remember the ratio, we have to work with similar units. So we have to say 4 centimeters, we convert the 20 kilometers to what? 2 centimeters. And we have done our conversions. Remember the kilometer, meter, centimeter, and the millimeters. Don't forget this one. You multiply by 1,000, you multiply by 100, and then you multiply by 10. Don't forget. So we have converted the 20 kilometers towards 2 centimeters. We have multiplied by 100,000 to get the 2 million. And then now we say, we simplify in a ratio form. Now we want it to become a unit ratio, 1:2. Then now we have the same units. 4 centimeters, we divide by 4 so that we get a 1. And then we say now 2 million. We say 2 million, we divide it by 4. It will give us 500,000. So we know that 1 unit on the map will represent 500,000 in reality. But on a bar, we say 4 centimeters will represent 20 kilometers in reality. So there's the unit. I have already done that on the previous slide because I wanted to show you how to write it. Now let's have a look at this one. They say, example, given the bar scale below, if the measured length is 10 millimeters, it means they have measured 10 millimeters. Calculate the real or the actual distance in kilometers. Now we are given the bar scale. With our bar scale, let's quickly have a look. It says 2 centimeters is to what now, or is equals to what? 250 kilometers. And there's another way of doing it. Am I going to work with 2 different units? No. Remember, I have to convert to the same unit, but we have a lead. what leads us, they say the answer must be in kilometers, and already we have a kilometer. Then they want to know the 10 millimeters. Now 10 millimeters are equals to how many kilometers in reality. So now for us to get this one in a ratio form now, then we have to say, okay, if this is 2 centimeters is equals to 150 kilometers, then I want to make it a unit ratio. I will divide by 2. I will divide by 2. And then I get 1 centimeter is to what? Is to 75 kilometers. You see the way I've done it. Remember, now I'm just using the bar. And then the 10 millimeters, then I go back to my question. Then the 10 millimeters, I have to convert it to what? To the centimeters. And I know that 1 centimeter is equals to what? 10 millimeters. So that means here I also have 1 centimeter is to unknown. Then I've converted this, and then if I multiply this by this, if I multiply the 2 because it's a bar, then I'll just say the answer here is what it is, 75 kilometers. 1 multiplied by 75. That's another way of doing it. But the other way of doing it, according to the step by step, then we have to convert the 150 kilometers into what? Into centimeters. And then remember, we said from kilometers we multiply by what? By 100,000. So it means we'll say 2 centimeters, and then we quickly multiply it by what? Sorry, we said 2 centimeters here, it's fine. And then the 150 kilometers we have to convert. We don't do anything here. We first have to start by converting the kilometers to centimeters, and then here we multiply by what? By 100,000. And then 150 we multiply it by what? By 100,000. It will give us how much? Let me get a space. It will be 15 million, 6 zeros, 6 zeros. And then now we will say 2 centimeters is equals to, or is to what? 15,000, 15 million. 1, 2, 3, 1, 2, 3, 6 zeros. And then now we have converted the 10 millimeters, and then we say it's 1 centimeter. We have done the conversion here, and then is to unknown. And then we multiply there, 1 multiplied by 150, so it will be 1 million multiplied by 1 divided by 2. Then it will give us what? 75. 75 what? We divide this by 2. It will give us 7,500,000. And then we convert. We divide by 100,000. And then our answer will be 75 kilometers. I hope you got it. That's how we do our conversions. Now let's quickly have a look at advantages and disadvantages of the number scale. Number scale is more convenient to use when working with small scales. Any unit, millimeters, can be used when using a number scale, and which can be converted to another appropriate unit, e.g. kilometers, meters, and so on. But what will be the disadvantage? When maps or plans are resized, then made bigger or smaller, the number scale becomes inaccurate. Calculations required to determine the actual length and distance. So meaning it is having a bit more work when we now do the calculations, because now we'll have to calculate the actual and also the distance when we're using the number scale. And then with this number scale, remember we have the number scale. So if I reduce or if I enlarge, it will become inaccurate. Those are the disadvantages. But when it comes to the bar scale, quick and easy to use, I think you have seen from the previous example. And when maps and plans are resized, the bar scale is also resized and still remains accurate. So when they are resized, they remain the same. So measurement using the disadvantage is measurement using a ruler obtained using bar scale tend to be less accurate, because sometimes, like I said, we don't know how to measure. The other person will be measuring, will just take a ruler and start measuring from 1, not start measuring from 0. Always when you measure, start from 0. And then bar scale may still require calculations to determine the distance or length in reality. Remember from that example, we have converted the bar scale into ratio scale, and then we were able to do our calculations. Now, what are the possible questions? These are the possible questions that can be asked when working with scales. Number 1, explain the meaning of the scale of the given scale. We have done that. You will see when we do the activities now. And then use the given scale to determine the actual distance of a map or a plane. Use the given scale and the actual dimensions to determine the map distance. Determine the scale of the map. Determine the scale of a drawn plane or map, meaning here we have to determine the scale. Here we are given the scale and the actual dimensions to determine what? To determine the map distance. So you must be given 2 to get the third one. Here we will be given what? They can ask us to use the given scale to determine the actual distance of a map. So we are given the scale to determine the actual distance. Or maybe they say, explain the meaning of the scale. Convert the given bar scale to a number scale. Discuss the advantages or disadvantages of using a bar or number scale. Situations in which one type of a scale is more appropriate than the other type of a scale. Now, let's have a look at activity 1. If a map has a scale of 1:500,000, and a distance on the map is 15 centimeter, calculate the real life distance in meters. Now here, what are we given? The scale. Let me work from this side. Okay, the scale that is given 1:500. And then now they're telling us 15 centimeters is a distance measured. So this distance is on the map. It's 15 centimeters. But remember what we said. We said when we work with a scale, we don't include the units. So there are no units there. Just write the scale as it is. Now I'm substituting because I'm given the map, and then the map is equals to what? Now they want the distance to be in real life in meters. You must check distance in meters. So meaning when I do my conversions, then I multiply, cross multiplication. And it will be 1 multiplied by unknown is equals to 500 multiplied by 15 centimeters. Let me quickly see. 500 multiplied by what? Multiply by 15 centimeters. It will give me 7,500 centimeters. But do they want the answer in centimeters? No. They want the answer in what? In meters. Then I have to go back to my conversion board. And then I know if I'm doing the right thing. Then on my conversion board, it says from kilometer, multiply by 1,000, and then multiply by 100, multiply by 10. Now I want to convert from centimeters to meters. That means I have to do what? Divide by what? By 100. Then I just take this and say 7,500 divided by 100. Divided by 100. my answer will be what? 75 meters, because I have to divide by 100. Can you see how easy? Now we are applying the skills of conversions. We have already done the conversions. Now it's becoming easier for us to do these conversions. And don't forget to write the units as I have written the units. Now let's see. Number 2, activity 2. Mpho bought a coffee table with the following dimensions: 1.4 meters multiplied by 0.76 meters. So meaning the length is 1.4 meters, and then the width is 0.76 meters, and the scale used was 1:10. Write down the map dimensions in millimeters. So it means here our scale is in millimeters. Therefore, what we do, there are 2 ways. We can just substitute with the 1.4, and then we get the answer, we convert it. Now let's see the length. What are we given? The actual length. The actual length is equals to 1.4 meters. And then the scale, now we have to use the scale now to get the map distance. Then we say 1:10. And then what we are given is what? Is the 1.4 meters. Now here, boys and girls, as you can see, I'm going to use my scale. Now for me now to get here, to say the unknown is what? 1.4 is equals to what? In reality now, it will be unknown. I have to multiply it by 10 and then multiply this one by 1.4. So meaning it will be unknown multiplied by 10 is equals to 1.4 meters. And then because I don't want unknown multiplied by 10, I have to divide by 10. I have to divide by 10. And then this will cancel out. And then unknown will be, let me go to my calculator, 1.4 divided by 10. It will give me 0.14. Now it's in what? It's in meters. This 0.14, it's in meters. Do I want my answer to be in meters? No, my answer must be in what? In millimeters. So now I know, let me quickly do it here. I said kilometer, meter, centimeter, and millimeters. And then I know from here, I multiply by 10, and then I multiply by 100. That means it's 1,000. So meaning from meters to millimeters, I have to multiply now because I have to get my answer in millimeters. It will be 0.14 multiplied by what? By 1,000. Because they say from meters to centimeters, it's 1,000. It's not 0 here, it's 100. So now I multiply by 1,000. And then my answer will be now in what? 140 millimeters. And then now I go to this one now. I come to this one. The second one, the width. And remember, boys and girls, it's not only that we are using the A4. We also have the A3 paper, which is big. Then the width here, it says 0.76 meters. This is the actual. And then now we are doing the conversions. 1:10. We're using a scale. And then we say unknown is to 0.76 meters. And then I do my conversions. Remember, with my conversions, unknown will be equals to what? 0.76 meters. The way I have done it on this side, I will continue doing it the same way. I divide by 10. Let me say 0.76. I divide it by 10. It will give me 0,076 meters. And then I take the very answer, I'm converting it now to what? 2 millimeters. Here now we are saying unknown is what? We are determining what? The map. So meaning our unknown, it is the map distance. So our map, it will be 0,076. We multiply it by 1,000. We multiply it by 1,000. It will be what now? 76 what? Millimeters. So we are done. We get the marks. Now let's quickly move to question 3. Activity 3. So boys and girls, now with activity 3, we are given the actual distance between Bilabila and Tzaneen via N1 is 262 kilometers, and the map distance is 9 centimeters. That is our starting point. So now we say in a ratio form, it is map is to what? Actual. Map is to actual. The map is 9 centimeters. The actual is 262 kilometers. But are we given a bar scale? No. So it means we're just given information here. They say determine the scale used on the map. Now, how do we determine the scale? Remember the ratio. Now I've written it in a form of a ratio. And then I have to convert these kilometers, because the map we are using the smaller units, which is centimeters and millimeters. I have to convert the 262 kilometers into what? Into centimeters. And then we said before I can I do this, if you allow me, I'm converting the 262 kilometers to what? 2 centimeters. And then we said it's kilometer, meter, centimeters, and millimeters. And then from kilometer to centimeter, here we multiply by 1,000, here we multiply by 100, which should be 100,000. So we'll say 262 multiplied by 100,000. Then it will be 262 multiplied by 100,000. It will give me 26,200,000. Now I'm go back to my scale. 9 centimeters is to what? Is to 26,200,000. And then centimeters, because now I want the scale in a unit ratio. I divide by 9. I also divide by 9. Then I will get 1 here, and then this side I divide by 9. My answer will be 2,911,111. That will be the scale that they have used on the map. And sometimes they will show you the bar scale, or they will show you the bars. Now with this one, boys and girls, they are telling us that use the information alongside to calculate the actual length of the main bedroom. So here's the main bedroom, and that we know that the length, it is the longer side. And then the scale, they have given us the bar scale, and here it clearly explains to say here it's 1 inch, and then there's 2 inches. So now if we are to use the scale here, the scale given 1:10. 1 inch is equals to 10. 1 feet is equals to 10 inches. And then now we are given 6 here. 6 will be unknown, which is the actual. And then we just say the actual now, because we want the actual length. The actual length will be 6 multiplied by 10. 6 feet multiplied by 10, it will be 60 inches. 60 inches. 6 multiplied by 10, it will be 60 inches. Boys and girls, can you see here with the scales? What I love is that we are just applying what? We are just applying the ratios. Now let's come to this one. The scale of the floor plan is 1:100. The dimensions of the house are given in meters. The dimensions of the house are given in meters. Explain the meaning of the scale. 1:100,000. 1:100 in weights. So we are saying it says explain the meaning. 1 unit on the map is equal to 100 units in reality. So meaning 1 unit on the map is equal to 100 units in reality. We have explained the scale. Now they say use the scale 1:100,000, 1:100 to determine the drawing size of the length of the machine room. The drawing size, what are they looking for? They want the drawing size, meaning they want the map size. Let me give you a minute to do this one. Just 1 minute. Where is our room? Before I can give a minute, let's see which room are they referring to? The machine room. Where's our machine room? Here is our machine room. What are the dimensions? Here is the width. We have these dimensions. And remember we said the length is the longest side. And then what is the length of this machine room? Here is the length of the machine room. So meaning right down here, it means the length of the machine room is 4 meters. Because it's given like that. Remember from the previous question, before I can do this, what is happening? Let me just double click. Okay, let me do this. I want to go back to that question. Okay, we said the scale of the floor plan is 1:100, and then the dimensions of the house are given in meters. So meaning this 4, it means it is in meters. And then now here, it means this is 4 meters. And then we want now to know the drawing size. I'm just giving you a minute, just 1 minute to do it. Welcome back, boys and girls. I hope you got the answer correct now. I hope you managed to do what you have been doing since the beginning of the lesson, which is application. Now let's quickly go back to the question. What are we given? We are given the actual, and then we have to determine the drawing. Now we say the scale 1:100, and then what we are having here, it is 4. We need what? The map. We need the map distance. We say it is 4 meters. And then, can I work with 4 meters? Let's see. 2 different units. Because now I want the smaller unit. And then I know this 4 meters. I have to do what? Convert it to what? Now, to centimeters. Then I say, okay, fine. Since I'm looking for this one, then it will be the map multiplied by 100 divided by 4. So now let me quickly do it and say the map multiplied by 100 is equals to what now? For this 4 meters, I must work with same units. And then the units that I am looking for, it's what? It is centimeters. And then I know from a kilometer, from a meter to a centimeter, I must multiply by 100. From kilometer, meter, centimeter, and millimeters. So from here to here, I must multiply by 100. That means I'm going to multiply by 100 so that I have the units, I have the same units. And then this means it will be 400. And then it will be now what? 400 what? 400 centimeters is equals to the map multiply by 100. I divide by 100. I divide by 100. And then this one, it will cancel. So the map or the drawing will be what now? It will be 4 centimeters. You see, boys and girls, so easy. I am just applying. It's an application. Now, it says a statement was made that the scale given above is not very accurate if the floor plan is resized. Is the statement correct? Give a reason for your answer. Now this, it takes us to where now? To the advantages and the disadvantages of what? Of a bar scale and of a number scale. But here we are given the scale as a ratio scale. So now we say, yes, it will be incorrect. The scale that is given, they said it is 1:100. So they say a statement was made that the scale given above is not very accurate. We say yes, that is 1 point. Just for saying yes, it is 1 point. Why? Because remember what we said, what are the disadvantages of what? Of a number scale. We said with the disadvantage, when resizing, they say give a reason. So is the statement correct? Yes, it is not very accurate. Why? We must give a reason. When we're resizing the dimensions of a scale, the dimensions of a scale are doing what? They also change. They also changes. So when resizing, the dimensions are affected. They also change. So what will be the best appropriate scale to be used there? It will be the bar scale. That one, remember, when we resize the map, then the bar scale is also resized and it does not affect the bar scale. So it will be best if we use what? If we use the bar scale. But in this instance, we say yes, it will be incorrect because now once we resize the scale, then the dimensions also changes. They are affected. Now let's go to what? To activity 6. Now with activity 6, boys and girls, what are we saying here? Let's have a look. The map of Qatar surrounding countries is shown in Annexure B. Here is our Annexure B. Boys and girls, the Annexure B, it will be the extra sheet that will be given to you. And this extra sheet will clearly show every detail of the map. It will be enlarged, it will be made bigger. And remember, in real, it is big. But because it is on a map, it has been resized. Now we say, the map of Qatar and surrounding countries is shown in Annexure B. Use the information in Annexure B to answer the following questions. Name the capital of Bahrain as shown on the map. Now, where do we go? We go to our map. On our map, we are given the Qatar international boundaries. They show us this straight line is you go to the keywords, and then how do we identify the capital? How do we identify the capital? Here, with a star, according to our keynote, and then we look which are we talking about, which capital country or which place are we talking about. We are talking about Bahrain, and then there it is. What is the capital of Bahrain? There it is Manama. Manama is the capital. It's there, boys and girls. There's the answer. It's a capital. So that means you don't need to stress because the capital is given. And then we go to the next question. Identify the type of scale on this map. Here's the scale given on the map. Here is our scale. What is this scale? It is a bar or a line scale. Boys and girls, it's very easy. I just identified and then I got the answer because I can see it's a bar scale. And then now we go to the next one. It says the map of Qatar and surrounding countries shown in Annexure B, convert the scale to a number scale. Write in the form of 1:2. Remember, what did we say with this one, boys and girls? We use this, what we call a ruler. You take your ruler, but here I'm just going to demonstrate, but I hope you'll see it. It won't be clear, but in real, now when you get the question, it will be clear. It will be a bigger map. That is maybe on an, yes, not that is maybe, it will be a map on an A4 page. Now you take your ruler, and then on your ruler, you must check, okay, there is my 0. And then there is my 1. You take your ruler, you go straight into your map, and then you place it. Remember, now we have to convert, we have to measure. Now when you measure here, you say, okay, from one place to the other, you just measure accurately there. And then when I measure there from 0, and then there you go. I hope you can see, but when I was doing this calculation, I have measured 2,9 to say this bar when I measure. Remember, it depends on the ruler that you are using. So you take your ruler, you measure exactly the length of the bar in centimeters. Why did I say it is 2,9 centimeters? Why was I able to say 0.9? It's because I used the millimeters. Then I measured. When I measured with the ruler, and boys and girls, use the ruler that is clear, that you can tell this is where my 1 starts from. And I would advise that when you go for the exams now in June, go and buy yourself a new ruler. use a new ruler, not that one that is broken, where there is no one, where there is no zero. Okay, say suppose you are using the one that is broken, and then where it starts, where you start measuring, take it as your zero, and then you start counting. Then say suppose I have measured 2,9, and then now they say 2,9. When you look at this now, from here to here, I will try to measure. When I try to measure, because it has been rescaled, you see what we're talking about. This one, it won't change. Then when I was measuring using the actual paper, I measured 2,9. So now I would say now in my question, 2,9 centimeters will represent what? Will represent 50 kilometers, because I've measured from this point up until this point. From this point up until this point, because it is clear, then it's 50 kilometers. And then after I have done that, remember, step number 2, I have to convert my 50,000 kilometers now into what? Into centimeters, because I have to use same units. And if they want you to use the miles, you have to work with the miles. If they will give you the conversion factor. If they want you to use the centimeter, the kilometers or centimeters, you will use the centimeters. So I have used the centimeters. I have measured the bar, and then that bar from this end to 50 kilometers, it gave me 2,9. And then now let me convert the 50. Now, step number 2, I have to convert. Where can I write it? Can I write here? And then I say convert 50 kilometers to what? To centimeters. What are we going to multiply with? We're going to multiply with a million. If I may write, if you can allow me to write it here, kilometer, meter, centimeter, and millimeters. So from kilometer to meter, I multiply by 1,000, and then from meter to centimeter, I multiply by 100. So now it means I'll be multiplying by what? By 100,000. So meaning the 50, then I'll say 2,9 centimeters is equals to, let me quickly use my ruler. 50, I am multiplying it by 100,000. Then it will be 5 million. So meaning I must write it in a ratio form now. 2,9 is to 5 million. Yes, 5 million centimeters. Then I will divide by 2,9. I divide by 2,9. And then now, because they say write it in a form of a ratio, 1:2, then 2,9 centimeters, and then they cancel out. I get a 1, and then I divide this by 2,9. And then as I divide it by 2,9 now, I will get my answer to be 1,724,137, 931. So meaning it would be 1:1,724,137,931. That is the scale that they have used for this particular question. You must bear in mind, you must capture that scale. And then remember again, boys and girls, when you work, you just round it off to be 1,724,137. And then you can round it off to be 138, because this 9, it will affect, it will be 138. Now that is the scale. Let's go to the next one. A tour guide stated that At Alcal is the tour guide stated that Alcal is 45 kilometers away from Doha. Verify showing all calculations if the statement is true. Now, what you need to do, you need to measure now. You say from Doha, there is Doha, and then there is our Alcal. You have to take your ruler, and then when you take your ruler, you have to measure from this point up until there, and then you have to measure from here coming straight to here. And when you measure point to point. And then remember our scale now. Our scale, when we measured, we say according to the measurement, I measured 2,7. I measured 2,7 what? Centimeters. This one, it is the map distance. Then if this is my map distance, and then my scale, I said it is 1:2. I wrote it somewhere so that I don't forget it, because it will be difficult for me to see it. It will be 1:1 million. Okay, there I've got it. 1 million, 1,724,137. 138, because remember I have rounded off. 138, that is the scale. And then now 2,7, what I have measured is to actual. Then we are verifying, we are recalculating what the tour guide said. And then now when we do it, we say the actual. Now the actual is equals to 1,724,138. We multiply by 2,7. I take this, I multiply by 2,7. And then my answer will be what now? My answer will be 4,655,172. That will be my answer if I use the entire scale as it is, and then that will be the answer that I get. But this answer, it is in what? It is in centimeters. And now I have to do what now? I have to convert. Now when I convert the centimeters to kilometers, kilometer, meter, centimeter, and millimeters. And then when I have to convert from kilometer, multiply by 1,000, I multiply by 100, and then this was in what? It was in centimeters. Then I have to divide this answer now. I have to divide my answer by what? By 100,000. I have to divide this answer by 100,000. This answer divided by 100,000, and then I got my answer to be 46,55, which is 46,7 kilometers. Now it's in kilometers. So remember, the tour guide stated that Alcal is 45 kilometers away. Did we get the 45 kilometers? No. So it means this statement, the statement conclusion, the statement is not true. That is the conclusion. Boys and girls, we're left with one, but unfortunately we have come to the end of our lesson. But it was just one activity, and even in this activity, it's so simple. We have done the meaning of the given scale. So meaning, if this given scale I'm just going to explain it. If it's a given scale 1:18, it means the one unit on the map will represent 18 units in reality. So meaning the shed that you see here on the map, it is 18 times bigger in reality. On the map it's 1 unit, and then but in reality it's 18 times bigger. Or maybe on the map, in reality it's 18 times bigger, and or on the map it is 18 times smaller. So it still explains the same. 1 unit on the map represent 18 units in reality. Boys and girls, this one, it was so easy because we're just going to do the conversions again and answer the questions. Unfortunately, like I said, it is the last activity, but the time is not there. I have a homework for you. I'm going to share the slides with your teacher, and then your teacher will give you the homework. And even with this homework, what you do, you just apply what we have learned, because you are given the bar scale. You do the application, and then this is your homework, all of it. You do it, and then your teacher will assist you. But don't forget, at the end, what we have worked with, we have worked with the given scale to determine the actual distance. We have worked with the given scale to determine the actual distance of a plan or a map. And we also worked with the given scale and the actual dimensions to determine the map distance. We have also determined the scale of a drawn plan, and then we have converted the bar scale to a number scale. So it means with the activities that you have covered, we managed to do everything that is on our summary. And you mustn't forget, this topic will be there in your June examination. So when you get home, go through this topic again, revise this lesson, and then make sure that you are ready for the exam. Now, next week, join us again, boys and girls. What time? On the 21st of May, from 2:30 to 4:00, where we'll be focusing on the maps. And then now we know that we have concluded the term 2 topics, or which is the paper 2 topics, and it means you'll be ready after the next week's lesson. Then we'll be doing the revision. So it means you'll be ready with the paper 2 topics. You know, you have covered the first part, which is measurement. Now we have covered the scale, which is the second part of the paper 2, the maps and plans and other representations of the physical world. We have covered the scales. Now next week, on the 21st of May, same time, 2:30 up until 4:00, we'll be focusing on the maps. Thank you for watching this lesson, and hope to see you next time. Have a lovely day, boys and girls.